Okay, so anytime you've removed one electron, the second electron that you remove is always going to take more energy than the first. The reason for that is because you've now taken away an electron, which means there is now less repulsion. So the nucleus is holding on to those electrons that are left behind a little bit more. So what happens is, anytime there are electrons leaving, you're now reducing the amount of repulsion. So if we were to remove a third electron, the third electron energy is always going to be more than the second for the same reasoning. You have now less repulsion, so the nucleus is holding on to those electrons more, the ones that are left behind. So a couple of things to think about. So what group would have the lowest energy needed to remove an electron? So it's always going to be actually group number 1, the alkaline metal group. So they have one electron in their valence shell, but the reason why it's so easy is not because it has one valence electron, it's because it has the lowest effective nuclear charge. So of all the groups on the periodic table, group number 1 has the lowest attraction of its valence electron to the nucleus. Okay, so what group would have the highest energy needed? Of course, the noble gases. So the noble gases already have a stable octet, and they have the highest level of the effective nuclear charge of any group on the periodic table. So meaning the nucleus of a noble gas is holding on to its valence electrons the most out of all the other groups found on the periodic table. So in general, right, so here's our trend. As you go from left to right, the electron to be removed will become harder and harder to do, right? So the ionization energy goes up and up and up. And as you go down a group, the amount of energy needed to remove an electron becomes less because you have more and more shielding happening. So meaning the electrons are not being held onto the nucleus as tightly. Okay, so our next trend is a term called electron affinity. So it's another type of energy requirement, but actually it's a different point of view here. So ionization energy is the energy needed to remove an electron. Electron affinity is the amount of energy that is released when an electron is added. So meaning this is when we're talking about gaining electrons. So when we have an electron that is gained into an atom, there is an amount of energy that is released when that happens. The higher the energy release, the more that atom wanted to gain or needed to gain that electron. Okay, so electron, think of affinity means like an attraction or a want. So the higher the energy release, the higher the electron affinity was for that electron, and vice versa. If the energy released is low, that means the affinity for that extra electron to come in was also low. So electron affinity tends to increase going across the periodic table. Okay, so one exception is the noble gases are not considered here. And the reason why is because noble gases will not add in any more electrons. Okay, but going from left to right, this is true. This trend will increase going across a period. And the reason for that is because it has to do with, again, the nuclear charge. So you have to remember that as you go across a period, and it all goes back to this original idea. As you go across a period, the atom is smaller and smaller, which means the nucleus is attracting the electrons more and more. So you have to think, if an electron is going to add into an atom, it's going to be very easy to add the electron in if the nucleus is pulling it in. It's attracting that electron in. As you go down a group, it becomes more and more difficult to add in an electron because the nucleus attraction is not felt as much. It really all comes down to the nucleus. So electron affinity will decrease going down a group because you're going to have more shielding, that repulsion between electrons. So additional electrons are not going to want to be added in because there's already electrons that are repelling each other. Whereas if you have a situation where you have an attraction for electrons, it becomes relatively easy to gain more electrons, of course. So in general, going to the right, you are increasing the attraction. Of course, we are ignoring the noble gases when we're discussing this. So technically, the ones that can attract electrons the most, has the highest electron affinity, would be our halogen group. As you go down a group, you have a lower and lower attraction for electrons, or the affinity. The energy when an electron is gained becomes less and less. Okay, so we're on our last concept here, our last trend on the periodic table. So this is a term called electronegativity. This is going to become very important, especially when we continue forward in this next chapter of this unit. And actually, to be perfectly honest, this idea and this concept is very important in chemistry in general when we're discussing compounds and molecules and how molecules interact with each other. So this is an important one to know, but don't worry, we are going to go over this again when it comes time to do that in the follow-up chapters. So what is this electronegativity? It's a measure of the ability of an atom in a compound. So this is important to make note of. When we're referring to this term, we're only discussing when you have more than one atom bonded to each other. So this doesn't happen with individual atoms. This is when you have a compound that is made. Okay, so what this is talking about is what is the ability of an atom in a compound to attract electrons. The higher the electronegativity, and I use En for short here, the higher the attraction for electrons. The lower the electronegativity, the lower the attraction for electrons. So if you think of this, attraction for electrons, this has to do with the same idea we just finished talking about. As you go from left to right, it tends to increase going across a period. So let's look back at the radius. So of course, as you're going to the right, the nucleus is attracting electrons more and more, which makes sense. It's going to attract electrons in a compound more and more. As you go down a group, you have more shielding that is happening, so the attraction becomes less and less. It's the same thing. It's very repetitive. Once you understand one concept of how the radius impacts all of these trends, it's essentially, repetitive here. So as the radius decreases in an atom, the electrons are closer to the nucleus, so they're attracted to the nucleus more, which is why the attraction level goes up. The electronegativity will decrease going down a group or stay the same, but in general they tend to decrease, and that's because the electrons are further from the nucleus because of the increase in shielding that is occurring. Okay, now there are exceptions to this trend, and you'll see in this next picture what I mean by that. There's going to be exceptions to every trend or every model that we look at in chemistry. But in general, so when we're talking about trends like this, like increasing or decrease, we're looking for the general idea. So for example, if we go across this period here, period 4, we have 0.8, 1, 1.3, 1.5, 1.6, 1.6. So notice here, this dipped down a little bit, right? It's supposed to be increasing. But if you were to look, yes, you do have exceptions that will lower in electronegativity. But in general, if you were to look at any of the rows, it does tend to increase going from left to right. Now notice the noble gases are not here. The reason for that is because, remember, this is a measurement in a compound. Noble gases do not make compounds because they're not able to make chemical bonds. right? They have a full valence shell. So when we're looking at this trend, it's similar to electron affinity. We pretty much just ignore the noble gases because they're not going to be making bonds. Okay? And of course, as you go down a group, the electronegativity tends to decrease. So again, you're going to see some exceptions when you look at these values. But in general, that trend tends to be true. Okay? Also, I want you to make note of, so notice these numbers. The highest number that it goes to is actually 4. And of course, it can go below 1. So the highest attraction for electrons in a bond or in a compound is fluorine. This should make sense. If we go back to this picture, you have to think which atom is attracting electrons the most. So of course, helium is a noble gas, right? Remember, noble gases, we're not looking at an electronegativity. So fluorine is the furthest to the right, which means it has the highest nuclear attraction, and it's the top of this group, which means it has the lowest amount of electron repulsion, pardon me. So not only do you have a strong attraction to the nucleus, you also have less electrons that are repelling one another. So yeah, fluorine is going to have a big time attraction for electrons, which makes sense when we look at our electronegativities. So on your periodic table, you also have these numbers. This is not something you need to memorize or know. This is essentially just like a data chart. So you will have access to these numbers all the time. It's just more so understanding the trends and why these trends are existing. So to summarize, as you go from left to right, the attraction for atoms when you have a chemical compound become higher and higher, of course, ignoring the noble gases. And as we go down a group, the attraction for electrons when you're in a chemical bond become less and less. Okay, and this last slide that's here is basically a summary of all 4 trends that we looked at. So the part about ion radiuses was just a little information to understand what happens to atoms when they become ions. But really, we looked at 4 trends. So atomic radius, ionization energy, electronegativity, and electron affinity. So actually, if you notice, all of them are pretty much the same, except atomic radius is the opposite. So as we go from left to right, the radius gets smaller, but everything else increases. As you go down a column or a group, the radius gets larger and everything else decreases.